All right, this is my favorite problem of the whole section. I am going to subtract these rational expressions. They do have different denominators. And in order to get a common denominator, I do need to factor both of these. So the fraction on the left, the rational expression on the left, is going to be 4 over. Now to factor this, I know that it is easy 1. So I can go straight to my two binomials, x and x, two numbers that multiply to give me 15, and that subtract to give me 2. That's 5 and 3. If you're not good at factoring trinomials, this is a trinomial with a leading 1. You might need a little work on that. And this over here is going to be 7 over. It's an easy 1. It starts with a leading coefficient of 1. I'm going to have x and x, two numbers that multiply to give me 3, or 3 and 1. I am subtracting them to get a negative 2. So I need the 3 to be negative and the 1 to be positive. All right, now, what does the fraction on the left need? What is it missing to have a denominator like the one on the right? And it's pretty obvious that it's missing an x plus 1. And what does the denominator on the right need to make it look like the denominator on the left? What's missing? And that's going to be the x plus 5. All right, let me rewrite them, all with a common denominator. You can see now that my denominators are going to be the same. See this? And see this? They'll be the same. They're in different order right now. I'll go ahead and put them in order. I'll put them together. This will be x plus 1, x minus 3, x plus 5. All right, they don't have to be in any particular order. Minus, same thing over here, x plus 1, x minus 3, and x plus 5. Now my numerator on the left is going to be x plus 1 times 4. It's going to be 4 times x plus 1. And my numerator on the right is going to be 7 times x plus 5. 7 times x plus 5. All right, let's put them together. All is one fraction, all over this common denominator of x plus 1, x minus 3, and x plus 5. I'll go ahead and distribute. 4 times x is 4x. 4 times 1 is 4. Now over here when I distribute, I need to remember that this is a negative 7. Okay? I am subtracting the 7, which multiplies to both of these. So that negative tags along twice. So this will be minus 7 times x is a negative 7x, right? Minus 7 times x is a negative 7x. And now minus 7 times 5. And that's going to be minus 35. Okay, and this is the part where I see a lot of mistakes right here with this minus, so I'm going to write it in bold. Okay, I am subtracting this multiplication. All right, let's do some like terms. 4x minus 7x is negative 3x. Plus 4 minus 35 is minus 31. All over my common denominator of x plus 1, x minus 3, x plus 5. Most people will stop here. You look to factor the numerator, but nothing factors between these two, no greatest common factor. You will notice that the leading coefficient is negative, so I always like to take that step and divide out the -1 so that what's left is ready to cancel. This will be 3x plus 31, right, because I'm dividing a negative out of both of these. And now my denominator stays the same, x plus 1, x minus 3, x plus 5. Now that they are factored completely, I'm looking to cancel. I got my red pen ready. I'm ready to cancel, but nothing cancels out. When you're adding or subtracting different denominators, usually at the end, it's a letdown. You're looking to cancel, but nothing usually cancels.